In the silent expanse of the cosmos, where darkness stretches like an endless veil, the sun hangs solitary, a luminous sentinel adrift in a sea of void, surrounded by an ocean of emptiness that defies comprehension. It casts its warm glow into the abyss, illuminating nothing but the faint whispers of distant galaxies. No companions orbit nearby to share its light. The nearest stars remain unimaginably remote, separated by chasms that swallow time itself. This isolation is the quiet truth of the universe, a reminder that even the mightiest fires burn alone, their radiance lost in the infinite night. Yet, in this profound solitude, the notion of neighbors emerges, not as familiar presences across a shared horizon, but as fragile connections across the cosmic gulf. The stellar kin, though bound by gravity's subtle threads, lie beyond the grasp of human endeavor. The closest among them dwells more than 4 light-years distant a span where light, the swiftest messenger, takes years to traverse. It is a divide too vast for voyages of flesh and steel, where dreams of exploration dissolve into the ether. And still, this proximity kindles the imagination, a spark in the dark that hints at worlds unseen, at possibility whistling just beyond reach. For in the grand architecture of the stars, nearness is relative, a delicate balance between isolation and invitation. Where the universe teases with the promise of company, this nearest neighbor bears the name Proxima Centauri, a humble red dwarf that flickers dimly in the constellation of Centaurus. Invisible to the unaided eye, it conceals itself in the shadows of its brighter siblings, Alpha Centauri A and B, orbiting them in a slow, eternal dance that spans over 500,000 years. A small star, low in mass and faint in luster, it burns with a subdued crimson glow, to modesto rival the sun's brilliance. Discovered over a century ago by an astronomer peering through the veil of night, it has lingered in obscurity, its light armor whisper against the backdrop of the Milky Way. Yet, this unassuming ember harbors secrets, erupting occasionally in massive flares that lash out into the surrounding void, reminders of the volatile heart beating within its core. Proxima Centauri stands as a testament to the universe's quiet contrasts, a star that defies grandeur, yet endures in the eternal rhythm of creation. In its faint embrace, worlds circle planets drawn into the gravitational pull of this crimson guardian. Among them, one captivates the mind's eye, Proxima b, a rocky sphere slightly larger than Earth, nestled in the delicate band where temperatures allow forth possibility of liquid water. Orbiting its star in a mere 11 days, it traces a path close enough to feel the warmth, yet tempered by the dwarf's subdued heat. This habitable zone, a cosmic cradle where water might pool intuitions or carve rivers through ancient stone, evokes visions of mist-shrouded landscapes, where the faint red light filters through atmospheres thick with potential. Though the star's flares pose threats, stripping away fragile veils of gas over eons, speculative models whisper of resilient climate swirls where protective magnetic fields or dense clouds could shield nascent life from their stellar tempests. Perhaps beneath a perpetual twilight sky, vast seas reflect dim glow, their depths harboring the chemistry of beginnings, where simpler molecules dance toward complexity in the quiet forge of evolution. The smallness of Proxima Centauri belies its profound allure. A star that could fit within the orbit of Mercury around our Sun. It commands a system rich with intrigue, where modesty yields to mystery. Other companions may orbit as well as smaller world. Proximad, whipping around in just 5 days, and hints of more. Detected through the subtle wobbles of starlight or the keen gaze of telescopes like the James Webb. But itis Proxima b that stirs the deepest reflections. A planet poised on the edge of habitability, where the line between barren rock and thriving biosphere blurs into speculation. Could winds whisper through alien forests, or microbes stir in hidden pools? The star's red hue might paint the surface in eternal dusk, fostering ecosystems adapted to low light, where life, if it exists, evil visioned constraints unknown to Earth. These are not wild fantasies, but credible extensions of observed data atmospheric simulations suggesting possible water cycles, geological activity hinting at volcanic renewal, all drawn from the meticulous scrutiny of distant signals captured by humanity's vigilant instruments. Here, in this cosmic vignette, lies the philosophical core of our eternal quest, the question that echoes through the ages. Are we alone in the vastness? For millennia, gaze stern skyward have sought answers in the twinkling multitude, imagining civilizations in far-flung galaxies, their signals lost in the cosmic noise. Yet, the universe, in its enigmatic wisdom, may offer the first revelation not in some remote nebula, but in the quiet proximity of our stellar doorstep. Proximab, with its tantalizing position, challenges the solitude of existence, suggesting that life might not be a rare anomaly, but a subtle thread woven into the fabric of nearby stars. It invites contemplation of shared destinies, where worlds separated by light years mirror one another in their struggles for persistence, their atmospheres breathing in rhythm with the stars above. The emotional resonance deepens as one ponders the human heart's yearning. We dream of alien horizons, of skies alive with unfamiliar constellations, of beings whose thoughts traverse the same existential voids. These visions, born from the poetry of science and the ache of isolation, find their nearest embodiment in Proxima's realm, no longer confined to abstract infinities. The prospect of fatherness hovers at the threshold of our cosmic backyard, a mere whisper away in the grand scheme. It is a hook that tugs at the soul, blending awe with melancholy. For in reaching toward this faint red light, we confront not just the mechanics of planets and stars, but the profound mystery of connection across the abyss. What stories might unfold on that distant shore? What reflections of our own fragility await in its shadowed valleys? As the sun continues its solitary vigil, Proxima Centauri beckons, a dim beacon promising that the universe's greatest secrets may lie not in the distant unknown, but in familiar nearness of a neighbor's glow. In the shadowed vaults of the southern heavens, where the constellations of Centaurus stretch like ancient guardians across the void, humanity's gaze first turned toward a trio of lights that would redefine our place in the universe. It was the 19th century, an era when astronomers, armed with brass telescopes and unyielding curiosity, pierced the veil of night from observatories perched on remote hills. the skies above the southern hemisphere, invisible to the northern world, held mysteries that beckoned like forgotten ruins. Among these seekers was a Scottish astronomer named Thomas Henderson, who in the 1830s measured the parallax of Alpha Centauri, the bright beacon. That appeared as a single star but concealed a deeper enigma. His calculations revealed it as the nearest stellar system to our Sun, a mere 4.3 light-years distant, a cosmic stone's throw that ignited imaginations. Yet, this was no solitary wanderer. Observations hinted at companions, faint echoes in the gravitational dance, pulling at the threads of reality. As the 20th century dawned, the pursuit deepened, like a river carving canyons through time. Astronomers in South Africa and Australia, under the relentless gaze of the Milky Way, refined their instruments, charting the subtle motions of stars against the backdrop of eternity. Alpha Centauri resolved into two brilliant siblings, Alpha Centauri and B Yellow, and orange jewels orbiting each other in an elegant 80-year waltz. But whispers persisted of a third presence, a dim outlier lurking at the edges, evading detection like a phantom in the mist. The southern skies, with their crisp clarity unmarred by industrial haze, became a sanctuary for these celestial hunters. They pondered the architecture of the cosmos, wondering if proximity implied shared origins, fragments of the same primordial cloud that birthed our Sun. In this reflective pursuit, one could sense their philosophical undercurrent. Were we alone, or did neighbors await in silence? Then, in 1915, amid the turmoil of a world at war, a quiet revelation unfolded in Johannesburg. Robert Innes, director of Union Observatory, scrutinized photographic plates exposed under the Africanite. His eye caught a faint red speck, unassuming yet anomalous in its proper motion, the swift drift across the sky that betrayed its nearness. This was Proxima Centauri, the nearest in Latin, a red dwarf star so dim it required the patience of glass and silver to unveil. At just 4.24 light-years from Earth, it eclipsed even its brighter kin as the Sun's closest companion. Innes's discovery was a poetic irony. The nearest star was not a radiant equal, but a humble ember, glowing with the subdued fire of a M-type dwarf, its light a mere fraction of the Sun's brilliance. One might reflect on this cosmic humility of the universe, in its vast indifference, placing a whisper where one expected roar, challenging our assumptions about prominence and proximity. The realization dawned slowly, like the first light filtering through a forest canopy. Proxima was not merely close. It was bound gravitationally to Alpha Centauri A and B, forming a trinary system theta-bitted in a vast, millennia-long cycle. This faint red dwarf, with its surface roiled by flares and magnetic tempests, became a symbol of the unexpected. Astronomers marveled at its solitude in the foreground, a sentinel guarding the gateway to other worlds. Yet, beneath the all lay a deeper mystery. Could such a star harbor planets? For centuries, speculation had swirled around the idea of worlds beyond our own. As far back as the 16th century, Giordano Bruno envisioned infinite stars encircled by habitable realms, a philosophical Hesiban of reflection on the infinite. In the 19th century, as telescopes grew sharper, thinkers like Camille Flammarion dreamed of life on nearby stars. painting visions of verdant planets teeming with alien civilizations. These were not mere fantasies, but credible extrapolations from the uniformity of nature. The same laws that governed Earth must extend to the stars. Long before technology could confirm, the human spirit pondered, if Proxima was so near, might it hold mirrors of our own existence? The veil began to lift in the early to 1st century, as precision astronomy evolved into an art of subtlety. Instruments attuned to the faintest gravitational tugs allowed scientists to detect the invisible planets betrayed by the wobble of their stars. Radial velocity methods, measuring the Doppler shift in starlight as a planet's pull stretched and compressed spectral lines, became the key to unlocking hidden worlds. It was a technique refined over decades, drawing on data from observatories worldwide, where mirrors collected photons that had journeyed across the Gulf. In 2016, a global collaboration known as the Pale Red Dot campaign focused their gaze on Proxima Centauri, using the high-accuracy radial velocity planet searcher at the European Southern Observatory. In Chile, a marvel of engineering that could discern stellar movements as slight as a walking pace they sifted through. The noise of stellar activity, suspense built in the data streams, as signals emerged from the chaos. Night after night, the telescope captured this star subtle sway, a rhythmic pull every 11.2 days. Analysis revealed a planet of Earth-like mass, roughly 1.3 times our world's, orbiting Proxima at a distance where liquid water might persist the habitable zone. That Goldilocks band, neither scorched nor frozen. Proxima b, as it was christened, circled its red sun so closely that its year lasted mere days. Locked in tidal embrace, one face eternally day, the other shrouded in night. The announcement, made in August 2016, rippled through the scientific community and beyond, electrifying minds like a storm across a parched plain. Here was not just a planet, but a potential cradle of life, bathed in the ruddy glow of a flare-prone star. Credible interpretations abounded. Could microbial life cling to its twilight zones, where temperatures allowed water to flow? Or might atmospheres, thick with greenhouse veils, shield against the star's violent outbursts? In this discovery, one senses the philosophical white the universe revealing its secrets in layers, inviting reflection on our fragility and the boundless possibilities. Proxima b stands as a beacon, a world so near, yet veiled in mystery, challenging us to contemplate what lies just beyond the reach of our senses. The collaboration that unveiled it, spanning continents and cultures, underscores a universal quest. In the quiet precision of instruments, humanity inches toward understanding its cosmic neighbors. As the data from HARPS and its kin painted this portrait, the world paused, reflecting on the profound implication that the nearest star system might hold echoes of home, whispers of life in the eternal night. In the quiet expanse of the southern skies, where the constellation Centaurus stretches like a sentinel across the void, a revelation unfolded in the year 2016, a revelation that rippled through the halls of observatories and the minds of astronomers like a tremor from the depths of the universe itself. Proxima Centauri, the faint red ember that had long lingered as the sun's nearest stellar companion, harbored a secret. Orbiting this diminutive star, a world emerged from the shadows of data, Proxima b, a planet not unlike our own in mass, nestled in a zone where the alchemy of liquid water might defy the cosmic odds. This was no distant speck in a galaxy's arm. It was the closest exoplanet ever unveiled, a mere 4.24 light-years away a stone's throw in the grand architecture of the stars. The scientific community, accustomed to peering into absolute distances, found itself stunned, as if the universe had conspired to place a mirror of Earth at humanity's doorstep, challenging every assumption about isolation in the cosmos. Imagine the scene. Astronomers gathered around flickering screens in the Chilean Andes, where the European Southern Observatory's telescopes pierced the night like vigilant eyes. The data from the high-accuracy radial velocity planet searcher instrument revealed a subtle wobble in Proxima Centauri's lighter gravitational tug so faint it spoke of a planetary presence. This wobble, periodic and insistent, betrayed the orbit of a body with a mass roughly 1.07 times that of Earth, circling its star every 11.2 days. Proxima Centauri, a red dwarf star 1/8 the mass of the Sun and far cooler, with a surface temperature of about 3000 Kelvin, bathed this world in infrared glow rather than the golden light of our day. Yet, in this crimson embrace, Proxima b resided within the habitable zone, that slender orbital band where temperatures could permit water to pool as liquid, neither frozen in eternal ice nor boiled away into vapor. The discovery was not merely a dot on a chart. It was a seismic shift, as if the cosmos had whispered a long-held truth. The nearest star, of all the trillions scattered across the Milky Way, cradled a potentially life-bearing world. The statistical improbability of this find hung over the revelation like a veil of mystery. The galaxy alone teems with over 100 billion stars, each a potential forge for planets. And the observable universe expands that number into the trillions. A vast sea of stellar fires where worlds form from swirling disks of dust and gas. Red dwarfs like Proxima Centauri dominate this multitude, comprising some 70% of all stars' core, long-lived beacons that burn for trillions of years, outlasting the brighter gents. Yet, the odds of detecting a rocky planet in the habitable zone around any given star are slender. Estimates from missions like NASA's Kepler telescope suggest that perhaps 1 in 5 Sun-like stars hosts such a world. But for red dwarfs, the habitable zones are perilously close, squeezed by Thesta's feeble heat. Proxima b's placement was exquisite. At a distance of about 0.05 astronomical units from its star 7 times closer than Mercury to the Sun, it received approximately 65 to 70% of the solar flux Earth enjoys. This just right equilibrium, akin to Goldilocks finding her perfect bridge, allowed for surface temperatures potentially ranging from -30 topless 30 degrees Celsius, depending on atmospheric shrouds. But why here, around the very closest star? The probability defies easy calculation. A cosmic lottery where the winning ticket fell into humanity's lap. Astronomers pondered, in a universe so immense, where exoplanets number in the billions, The alignment of habitability with proximity seemed almost deliberate, as if stars had arranged themselves to provoke wonder. For centuries, the stars had been distant sentients, pinpricks of light that inspired poets and philosophers, but remained beyond the grasp of human endeavor. Ancient stargazers, from Ptolemy to Galileo, mapped them as fixed and eternal, realms of the divine rather than arenas for exploration. Even in the modern era, with telescopes unveiling galaxies billions of light years distant, the question of extraterrestrial life lingered as an abstraction, a thought experiment confined to equations like Drake's, which estimated the number of communicative civilizations in the Milky Way. Proxima Centauri itself, discovered in 1915 by Robert Innes from a South African observatory, was a faint curiosity, its parallax confirming its nearness but offering no hint of companions. The stars felt unreachable, their worlds hypothetical constructs in scientific papers. Now, with Proxima B's emergence, that veil lifted. The question of life transformed from a distant murmur to an immediate echo. No longer was alien existence a matter for light years of separation. It orbited a star visible to the naked eye from southern latitudes, a red glimmer that could, in theory, be reached by future probes traveling at fractions of light speed. The Breakthrough Starshot initiative, conceived in the wake of this discovery, envisioned swarms of nanocraft propelled by laser sails, hurtling toward Alpha Centauri at 20% the speed of light, a journey of mere decades. Rather than millennia, humanity's perspective cracked open. The cosmos was not an indifferent expanse, but a neighborhood. With Proxima B as the enigmatic house next door, its windows possibly aglow with the spark of biology. This paradigm shift reverberated through the corridors of science, reshaping exoplanetology from a field of distant detections to one of tangible prospects. Before Proxima B, exoplanets were often found around stars hundreds or thousands of light years away. Kepler 5 to be, dubbed Earth's cousin, lay 1,400 light years distant, a world forever beyond direct scrutiny. Proxima B changed that calculus. Its proximity allowed for unprecedented observational potential. Telescopes like the James Webb Space Telescope, launched in 2021, could peer at its atmosphere through transit spectroscopy, searching for biosignatures like oxygen or methane. The planet's mass, inferred from the radial velocity method that measured Proxima Centauri's 1.38 meters per second, wobble, suggested a rocky composition, perhaps with iron core and silicate mantle akin to Earth's. Speculative models painted vivid possibilities. If Proxima B retained a magnetic field, it might shield an atmosphere from the star's flares eruptions that could strip away gases, like a cosmic wind eroding stone. Without it, the world could be a barren rock, its surface scarred by radiation. Yet, credible interpretations leaned toward hope. Simulations from NASA's Goddard Institute for Space. Studies explored climates where tidal locking created a perpetual day side and night side, with wind circulating heat to form equatorial oceans or vast ice sheets that trapped water beneath. The planet's slightly larger size, potentially 1.1 times Earth's radius, implied a gravity about 10% stronger, where hypothetical life forms might evolve sturdier frames, adapting to a world where the horizon curved more sharply. The tantalizing Earth-like qualities of Proxima be unfolded like layers of an ancient scroll, each revealing deeper mysteries. Its orbital dance placed it in a resonance where the star's light, predominantly infrared, could penetrate a thick atmosphere, warming subsurface waters even on the shadowed hemisphere. Models suggested that if the planet formed with a hydrogen envelope, it might have lost it over eons, leaving a nitrogen-oxygen mix reminiscent of Earth's primordial air. Oceans, if present, could span the terminator zone, the twilight band between eternal day and night, where moderate temperatures fostered chemical reactions akin to those in Earth's hydrothermal vents. The cradles of life. Climates varied in simulations. One scenario depicted an eyeball planet, with a liquid pool staring eternally at the star, surrounded by ice. Another envisioned dynamic weather patterns, with super-rotating winds carrying moisture across hemispheres. The star's flares, while destructive, might paradoxically drive prebiotic chemistry, their ultraviolet bursts sparking molecular bonds in the upper atmosphere. Proxima B's age, estimated at 4.85 billion years older than Earth's 4.54 billion, afforded ample time for geological processes. Plate tectonics could recycle carbon, stabilizing climates against runaway greenhouse effects. Yet, uncertainties loomed. The planet's formation in the protoplanetary disk of a flaring young star might have baked away volatiles, leaving a desiccated husk. Or, if it migrated inward from cooler orbits, it could have accreted icy materials, harboring subsurface aquifers teeming with extremophiles. These speculations, grounded in data from missions like Gaia and TESS, painted Proxima B not as a sterile rock, but as a canvas of potential, where the building blocks of life, carbon, hydrogen, oxygen, might assemble under crimson skies. Beneath the scientific scrutiny lay an emotional undercurrent, a tide of awe mingled with quiet fear that swept through the community and beyond. If life clung to Proxima B, perhaps microbial mats in briny pools or complex organisms. Gazing at a fixed star, implications cascaded like dominoes through philosophy and existence. The universe, once perceived as a lonely stage for humanity's drama, would reveal itself as a symphony of beings, where the Fermi paradox dissolved into a chorus of signals awaiting detection. Life's emergence, no longer a rare fluke on one blue marble, would imply ubiquity if the nearest habitable world bore it. Then billions more across the galaxy pulsed with biology, from methanogenic archaeoto-intelligences pondering their own skies. This prospect evoked a profound humility, a recognition that humanity's story was but a thread in a vast tapestry, woven by the same physical laws that governed distant worlds. Yet, the fear lingered, a shadow cast by the possibility of absence. If Proxima proved barren, stripped by flares, or locked in eternal sterility, it might whisper a harsher truth. Life as a cosmic anomaly, fragile and isolated, emerging only under exquisitely rare conditions. The Drake equation's variable star formation rates, habitable zones, intelligence fractions would tilt toward sparsity, suggesting that the great silence of the stars was not a puzzle but a verdict. In this reflection, humanity confronted its own vulnerability. Earth's biosphere, resilient yet precarious, might stand alone, a solitary flame in the dark. The discovery forced a philosophical reckoning, echoing through late-night discussions in observatories and quiet contemplations under starlit domes. For millennia, thinkers from Aristotle to Kant had speculated on plurality of worlds, debating whether the Creator would leave the cosmos empty or fill it with mirrors of ourselves. Proxima B made this tangible, no longer a metaphysical query, but a testable hypothesis. If biosignatures emerged, perhaps ozone in spectral lines or seasonal methanepiums, it would upend anthropocentrism, inviting questions of convergence. Would life follow DNA as helix or forge alien pathways? Ethical dilemmas arose: should humanity broadcast signals, risking unintended consequences, or listen in silence? The awe stemmed from proximity's intimacy. Proxima Centauri, part of the Alpha Centauri triple system, felt like Kinna's stellar sibling whose child mirrored our own. Fear, too, rooted in the unknown, red dwarfs longevity meant any civilization on Proxima B could be ancient, billions of years advanced, observing Earth as we now observe them. Or, in barrenness, it underscored life's tenuousness, urging stewardship of our world amid climate upheavals and extinctions. As the narration lingers on this cosmic threshold, Proxima B stands as a beacon of mystery, its secrets veiled yet beckoning. The scientific shock endures, not as a fleeting tremor, but as an enduring wave reshaping humanity's gaze upward. In the red glow of the nearest star, the universe reveals its artistry, a world poised between possibility and peril, inviting reflection on our place in the eternal dance of stars and planets. The journey to understand it continues, a slow unraveling of threads that bind us to the cosmos, where awe and fear entwine like the orbits of distant worlds. In the shadowed vaults of the cosmos, where stars whisper secrets across the void, the tale of Proxima B unfolds like an ancient scroll, revealing layers of mystery with each careful unfurling. As astronomers peer deeper into this enigmatic world, orbiting the dim red beacon of Proxima Centauri, they employ an arsenal of subtle instruments, each a silent sentinel capturing the faintest echoes of planetary existence. The journey begins with the radial velocity method, a technique that listens to the gravitational dance between star and planet. Here, the star's gentle wobble betrays the invisible pull of its companion, a rhythmic tug that speaks of mass and motion in the quiet language of stellar spectra. Through telescopes perched on earthly peaks, scientists measure these infinitesimal shifts in the star's light, refining the portrait of Proxima B as a rocky body, roughly the size of our own world, locked in a swift embrace around its star. Yet this method, elegant in its simplicity, offers only glimpses, a minimum estimate of the planet's heft, veiled by the unknown angle of its orbital path. Complementing this gravitational whisper is photometry, the art of charting light's ebb and flow. Observers track Vesta's brightness over time, discerning patterns that hint at the planet's influence or the star's own turbulent moods. In the case of Proxima B, these photometric vigils have helped disentangle the planet's signal from the star's restless activity, confirming its orbital rhythm of just over 11 days. A heartbeat so rapid it places the world tantalizingly close to the edge of habitability. Astrometry, too, joins this celestial symphony, mapping Vesta's precise position against the backdrop of distant luminaries. By tracing Proxima Centauri's minute wanderings across the sky, astronomers infer their gravitational nudges from orbiting bodies, adding strokes to the canvas of the system's architecture. Together, these tools weave a tapestry of inference, transforming raw data into a vision of a planet that might cradle oceans or cradle desolation. But the veil remains thick, for Proxima eludes direct sight, a phantom inferred only through its star's reluctant sway. Current telescopes, bound by the limits of resolution and distance, cannot pierce the glare of Proxima Centauri to behold the planet itself. It does not transit across the star's face from our vantage, denying us the shadow plate that would reveal its size and atmosphere with clarity. Instead, we are left with echoes and implications, a world conjured from mathematical ghosts. This invisibility breeds uncertainty, a philosophical pause in the narrative. What hidden facets lie beyond our grasp, waiting in the interstellar hush? As the investigation deepens, the system reveals further complexities, like ripples expanding on a still pond disturbed by an unseen stone. In the outer reaches, beyond Proxima B's intimate orbit, astronomers have detected signs of another wanderer, Proxima C, a larger sibling, perhaps 6 times the mass of Earth, tracing a wider path around Vesta, discovered through the patient accumulation of radial velocity data spawning years. This super-Earth candidate orbits with a languid grace, completing its circuit every 5 years or so, far from the star's fiery grasp. Its presence complicates the serene isolation once imagined for Proxima b, suggesting a family of worlds where gravitational harmonies might influence cyclids and evolutions. Could Proxima C harbor its own secrets, a frozen realm or a gaseous envelope, pulling subtly at its inner neighbor? The discoverer stirs reflections on cosmic architecture, reminding us that no planet drifts alone. Each is part of a grander orchestration, where distant companions shape destinies across the void. Venturing further into the system's fringes, observations from vast arrays of antennas in distant deserts unveil even more elusive features. The Atacama Large Millimeter Submillimeter Ray, a chorus of dishes attuned to the cold whispers of the universe, has captured the faint glow of dust belts encircling Proxima Centauri. These ethereal rings, composed of icy grains and rocky debris, stretch from 1 to 4 times the Earth's understance, a Cooper-like realm of remnants from the system's formative chaos. An outer belt hints at even greater expanses, perhaps tenfold farther, where temperatures plunge to absolute chills. Such structures evoke the debris disks of our own solar system, graveyards of unborn worlds or shattered moons. Whether they raise speculative whispers, might these belts conceal exomoons, silent guardians orbiting the known planets? Though direct evidence remains elusive, the dust's distribution suggests gravitational sculptors at work, perhaps moons tugging at the particulate sea, carving lanes and arcs in cosmic dust. In this dance of shadows, one envisions Proxima b not as a solitary orb, but as a hub in an intricate web, where moons could shield atmospheres or stir tidal forces. fostering environments ripe for the alchemy of life or its quiet extinction. Yet amid these revelations, the star itself emerges as a tempestuous protagonist, its nature a profound challenge to the fragile equilibrium of habitability. Proxima Centauri, a red dwarf of modest stature, burns with an inner fury that belies its dim glow. It unleashes flares of staggering intensity, eruptions of plasma and radiation that illuminate the surrounding void like celestial storms. These outbursts, far more frequent and potent than those of our Sun, hurl waves of ultraviolet light and X-rays across its planetary domain, energies that could scour surfaces and erode atmospheres for eons. Magnetic storms rage within its depths, twisting fields that amplify these cataclysms, sending charged particles spiraling into the void. For Proxima b, nestled perilously close in its habitable zone, this barrage besieges an existential riddle. Does the planet's magnetic shield, if it exists, deflect these assaults, preserving a cloak of air? Or has the relentless bombardment stripped it bare, leaving a scorched husk adrift in the stellar winds? Consider the ultraviolet deluge, a silent assassin that penetrates deep into planetary realms. Proxima b endures fluxes hundreds of times greater than Earth, radiation capable of dismantling molecular bonds, sterilizing surfaces, and driving atmospheric escape. In speculative yet credible visions, one imagines early epochs where the planet's primordial envelope boiled away under this onslaught. Water vapor dissociating into hydrogen and oxygen, the lighter gas fleeing into space. What remains might be a tenuous veil, perhaps sustained by volcanic outgassing or cometary gifs from the outer dust belts, but forever teetering on the brink. The flares, observed in their multi-wavelength glory, reveal peaks of brightness that dwarfed stars' quiescent light, moments when the system transforms into a cauldron of energy. Philosophical echoes arise in this hostile embrace. Habitability is not a static gift, but a dynamic struggle, where life, if it clings, must adapt to rhythms of destruction and renewal, burrowing deep or evolving shields against the stellar ire. These revelations deepen the central enigma, casting Proxima b in dual light as a potential paradise or a barren relic. Is it a verdant oasis, where liquid water pools beneath a protective sky, warmed by the star's infrared glow and shielded by geological fortitude? Or has Theseus's violence rendered it a desiccated sphere, its air long fled, surface-etched by radiation scars, a monument to cosmic indifference? The questions resonate like unanswered prayers in the night, probing the boundaries of possibility. In this reflection, one contemplates the fragility of worlds, how proximity to a star source of light and life can also sow seeds of ruin. Proxima b stands as a mirror to our own existence, a reminder that habitability is a delicate thread, woven from stellar temperament, planetary resilience, and the inexorable march of time. Yet hope glimmers on the horizon, as humanity sharpens with instruments forged from ambition and ingenuity. The James Webb Space Telescope, a marvel suspended in the Lagrangian hush, turns its mirrored eye toward nearby exoplanets, poised to unravel atmospheric mysteries. By capturing infrared spectra, it seeks signatures of gases, carbon dioxide, water vapor, perhaps even ozone, that could betray the presence of air and its composition. For Proxima b, Such observations might pierce the veil, revealing whether an atmosphere endures amid the flares or if it has succumbed to erosion. Scientists prepare meticulously, simulating signals and calibrating for the star's variability, building suspense toward that pivotal glimpse beyond Webb. Forthcoming missions and observatories promise even greater revelations. Ground-based behemoths like the Exoplanets Telescope, with its adaptive optics and high-resolution spectrographs, aim to detect reflected light from Proxima b, hunting for biosignatures in Exoplanets' glow. Instruments such as Harmony will dissect spectral lines, seeking gimbalances that hint at biological processes, oxygen's abundance or methane stress, echoes of life persisting against odds. Space-based endeavors like proposed interferometers or starshade concepts envision blocking the star's glare to image planets directly, transforming inference into vision. In the era of anticipation, the deeper investigation of Proxima b transcends science, becoming a philosophical quest to touch the essence of another world, to ponder if, in the vast silence, we are truly alone. As the chapter of inquiry closes, the mystery lingers, a suspended chord in the cosmic symphony. Proxima b, with its refined properties and shadowed threats, invites us to reflect on the universe-pruned ambiguities. In the flare's fury and the dust's quiet drift, inviewable of stars and the promise of telescopes, lies the eternal dance of discovery, slow, immersive, eternally unfolding. In the vast tapestry of the galaxy, where stars flicker like embers in an ancient hearth, red dwarfs emerge as the quiet multitudes, the unassuming guardians of cosmic longevity. These diminutive suns, far outnumbering their brighter brethren, comprise the majority of stellar inhabitants in our Milky Way, perhaps 3/4 of all stars. Scattered across the void, their existence unfolds over epochs unimaginable to human minds, spanning trillions of years. A timescale that dwarfs the brief flare of our own sun's anticipated 10 billion-year life. In this enduring stability lies their allure, a steady outpouring of energy, neither waxing nor waning with the volatility of larger stars, but a gentle, consistent glow born from the slow fusion of hydrogen in their cores. Yet, herein resides the profound paradox, a shadow woven into their light. For these red dwarfs, despite their tranquil longevity, harbor a tempestuous heart. Their surfaces convulse with magnetic fury, unleashing flares, eruptions of radiation and plasma that surge forth like solar storms, amplified 1,000-fold. These outbursts, observed through telescopes arrayed in the high deserts of Chile and atop Hawaiian volcanoes, release energies equivalent to the most cataclysmic events on our sun, bathing nearby worlds in ultraviolet and X-ray torrents that could scorch the very essence of life. One reflects on this duality as a cosmic irony, a star that promises eternity yet delivers destruction in spasms. Data from space observatories, such as those capturing the high-energy emissions from these dwarfs, reveal that young red stars flare with relentless frequency, their magnetic fields twisting and snapping like over-taut ropes. Even in maturity, As with Proxima Centauri estimated to be billions of years old, the activity persists, though tempered by time. Recent observations in early 2025, using networks of antennas tuned to millimeter wavelengths, have unveiled flares from Proxima that dwarf previous estimates. Outbursts so intense they illuminate the star's surroundings with a brilliance unseen in optical light. These events, documented in astronomical journals and shared among global correlates, suggest a star not merely active, but explosively so, reshaping our understanding of space weather in such systems. The paradox deepens when one considers the implications for planetary companions, red dwarfs, by virtue of their ubiquity and endurance, should be the galaxy's most prolific hosts of worlds. Yet their violent dispositions cast a pall over any hope of sustainability. The tension mounts, a suspenseful crescendo in the narrative of cosmic potential, as astronomers ponder the habitable zones encircling these crimson suns. Unlike the broad, distant bands around yellow stars like our own, the habitable zone of a red dwarf hugs close. A narrow anolis where temperatures might permit liquid water to pool on a planet's surface. This intimacy arises from the star's feeble luminosity. Proxima Centauri, for instance, emits but a fraction of the sun's light, necessitating orbits measured in mere days rather than years. Surveys of exoplanets, compiled from space telescopes scanning the heavens, indicate that rocky worlds abound in these zones, their numbers potentially eclipsing those around other stellar types. One envisions a galaxy teeming with such planets, each a potential seeded for life, their surfaces warmed by the ruddy hue of their parent star. Yet, the shadow of destruction looms. The flares, those magnetic cataclysms, propel charged particles and radiation that could erode atmospheres over eons, stripping away protective layers like wind carving stone. Studies from NASA's archives and European observatories highlight this peril. Without a robust magnetic field or thick atmospheric shield, a planet might lose its ocean's toe space, its surface bombarded by sterilizing rays that dismantle organic molecules before they can assemble into complexity. For Proxima b, this tension crystallizes into a poignant enigma, a world suspended in the balance of creation and annihilation, orbiting its red dwarf host at a distance that brings it perilous linear, completing a circuit every 11 days. The planet feels the inexorable pull of gravitational forces. This closeness, a mere fraction of Earth's separation from the Sun, ensures tidal locking, a phenomenon where the planet's rotation synchronizes with its orbit. One hemisphere forever facing the star in unending daylight, the other condemned to perpetual night. Observations subtug this lock come from radial velocity data and transit searches. Though the planet's edge-on alignment remains elusive, models predict it with near certainty, given the tidal torques that would have aligned it over geologic ultimuscles. Imagine the eternal day side, bathed in the star's crimson glare, where temperatures might soar to levels that boil water into vapor, while the night side plunges into absolute cold, freezing any moisture into crystalline jets. This dichotomy evokes a world divided, a metaphor for the universe's one bifurcated nature, light and shadow, warmth and void, challenging the resilience of any hypothetical biosphere. Yet, in the realm of climate simulations, hope flickers like a distant aurora. Scientists, drawing on three-dimensional model akin to those forecasting Earth's weather, but scaled to alien worlds, explore whether an atmosphere could bridge this divide. These computational tapestries, woven from equations of fluid dynamics and radiative transfer, suggest that a sufficiently dense envelope, perhaps rich in greenhouse gases like carbon dioxide or water vapor, might circulate heat through global winds, tempering the extremes. Data from such models, published in peer-reviewed repositories like those affiliated with NASA and the European Southern Observatory, depict scenarios where super-rotating jets carry warmth from the day side to the night, preventing total freeze-out. In one credible interpretation, if Proxima threatens a thick atmosphere, convection cells could rise on the illuminated hemisphere, spilling over to the dark side in a ceaseless cycle. Much like the ocean currents redistribute Earth's equatorial heat to polar realms speculatively, this could foster stable climates, where surface temperature hover in ranges conducive to liquid water. Even on a locked world, the challenge intensifies when contemplating the possibility of oceans. Those cradles of terrestrial life, persisting in second environment. Models indicate that water, if present in abundance, might pool in the twilight zones, the terminator belts encircling the planet, where day fades into night. Here, in this eternal dusk, temperatures could moderate, allowing the seas to lap against rocky shores under a sky perpetually tinged with sunset hues. Credible simulations, grounded in real planetary data from our solar system, Venus's thick veil, Mars's thin shroud, propose that Proxima oceans might migrate with atmospheric flows, evaporating on the hot side and condensing as rain or snow on the cooler fringes. One reflects philosophically in this, a world where life, if it emerges, might huddle in these liminal spaces, adapted to dim light and constant winds, evolving forms resilient to the star's whims. Yet, the models are not without caveats. They hinge on assumptions of atmospheric composition and planetary magnetism. If flares have eroded the air over billions of years, as some orbital data suggest, these oceans might evaporate into space, leaving a barren husk. Recent 2025 findings from X-ray observatories underscore this risk, revealing that Proxima's flares unleash particle winds capable of ablating atmospheres at rates far exceeding earlier predictions, a barrage that could render even robust shields tenuous. As scrutiny escalates, Proxima Centauri reveals itself as a star of defiant obscurity, its secrets unfolding layer by layer only to spawn deeper riddles. Initial detections painted a picture of promissory world in the habitable embrace, yet subsequent observations, amassed through ever-refined instruments, expose the harsh realities. Telescopes capturing infrared signatures and radio bursts have documented flares occurring with alarming regularity, some enduring for hours and amplifying the star's brightness manifold. A study from early 2025, utilizing arrays in the Atacama Desert, captured events where Proxima's millimeter emissions spiked dramatically, implying plasma ejections that could engulf its planetary system in ionizing radiation. This activity, more extreme than anticipated, suggests a space environment akin to a perpetual storm, where charged particles spiral along magnetic lines, bombarding any orbiting body. For Proxima b, this means a constant erosion of potential habitability, even if an atmosphere clings tenaciously. The flares might deplete ozone equivalents, allowing ultraviolet rays to penetrate and disrupt biochemical precursors. Speculatively, life could adapt, perhaps burrowing underground or thriving in subsurface oceans shielded by ice. But the escalation breeds uncertainty. Each new dataset, from collaborative missions scanning for atmospheric biosignatures, adds to the mosaic, yet the image remains fractured. Is this a cradle where microbial mats could photosynthesize under red light, or a trap where evolutionary sparks repeatedly extinguished? The philosophical tension simmers beneath these scientific inquiries, transforming Proxima b into a mirror reflecting humanity's dualities of hope and fear. In its locked visage, one discerns a test of life's fragility. Does existence require the gentle nurture of a sun-like star, or can it endure the rigors of a red dwarf's embrace? Credible theories, drawn from astrobiological frameworks, posit resilience life on Earth, after all, has weathered asteroid impacts and volcanic winters, suggesting adaptability in extremis. Perhaps Proxima b harbors ecosystems where organisms harness flare energy, evolving photorepair mechanisms to mend radiation-damaged strands of heredity. Yet, the fear lingers, a shadow cast by the star's volatility. If habitability proves illusory here, in our nearest neighbor, what of the galaxy's trillions of red dwarf worlds? This enigma invites reflection on our own precarious tenure. Orbiting a star destined to swell and consume in mere billions of years, Proxima b, in its mysterious poise, challenges us to contemplate the universe's indifference whether life is a rare bloom in stable gardens or a tenacious weed sprouting amid chaos. Deeper still, the escalation uncovers layers of interconnected mysteries. As models evolve to incorporate fresh data, climate simulations now account for the star's spectral peculiarities. Red dwarfs emit most energy in infrared, potentially allowing photosynthesis tuned to longer wavelengths, where alien flora might appear black to absorb the dim glow. But flares disrupt this equilibrium, injecting bursts of blue and ultraviolet light that could trigger photochemical reactions, forming haze layers that cool or warm the planet unpredictably. Observations from space-based platforms analyzing the star's light curve reveal variability that complicates these predictions. Periods of quiescence punctuated by megaflares, each capable of doubling incident radiation. In one interpretive framework, grounded in hydrodynamic models, such events might trigger global aurora on Proxima b, ionizing vapor atmosphere and accelerating escape processes. The night side, shrouded in darkness, could accumulate ices of water, carbon dioxide, and nitrogen, forming glaciers that slowly sublimate, feeding a tenuous vapor cycle. Speculatively, if the planet possesses a magnetic field generated by a molten core convecting in the tidal heat, it might deflect some particle onslaught, preserving a habitable niche. Yet, seismic data analogs from Earth suggest that tidalicking could stifle plate tectonics. starving the world of volcanic outgassing need to replenish atmospheres. The narrative builds suspense as we delve into Terminator's allure. That band of perpetual twilight where contrasts converge. Models depict winds howling across this divide, carrying moisture and heat in vortices that spiral like galactic arms in miniature. Here, oceans might persist, their depths harboring hydrothermal vents spewing minerals. Akin to Earth's deep-sea oases, where life thrives independent of sunlight. Credible extrapolates from microbiological studies propose chemosynthetic communities, bacteria feasting on chemical gradients rather than stellar photons, evolving in isolation from the surface's perils. But the escalation tempers optimism. 2025 analyses of Proxima's flare spectra indicate proton fluxes that penetrated, potentially mutating subsurface biota or sterilizing aquifers. This duality promise eroded by Paramero's broader astrobiological debates, where dwarf systems represent the galaxy's statistical bet for life. Yet observational biases favor detection around these stars, skewing our perceptions. Philosophically, Proxima B embodies the eternal quest for meaning in the void, a sentinel world probing the boundaries of resilience. If life clings there, it affirms the universe's fecundity, a testament to adaptability amid adversity. If barren, it underscores fragility, reminding us that habitability is not merely a zone, but a delicate interplay of forces. In this reflective gaze, humanity confronts its isolation, yearning for connection across the light years. Even as the mystery deepens with each revelation, the star's defiance, it flares a cosmic Morse code of warning and invitation, draws us onward, into the shadows where hope and fear entwine like the orbits of distant worlds. As the inquiry intensifies, layers peel away to expose further intricacies in the atmospheric dance. Simulations incorporating formation hazes from photoreactions suggest these could act as blankets, modulating temperatures to sustain liquid water across wider swaths. On the day side, evaporative cooling might cap heat buildup, while on the night side, greenhouse trapping prevents total glaciation. Data from analogous systems, like those around other nearby red dwarfs, bolster these views, showing spectral hints of water vapor that fuel speculative visions of cloudix, veiling the planet in perpetual mist. Yet, the flares intrude, energy cascades triggering nitric acid rains or ozone depletions that acidify potential seas. Recent 2025 detections of extended flare duration summer persisting for days imply cumulative damage, where repeated assaults could tip a habitable world toward desolation. Much like Venus's runaway greenhouse dot in contemplating the twilight zones, one visions ecosystems poised on the edge, where evolutionary pressures fork hardy forms. Perhaps microbial mats carpet the shores, their pigments optimized for the star's infrared peak, generating oxygen that builds a protective layer over eons. Models predict that if the planet formed with ample volatiles, cometary deliveries could replenish losses, sustaining a hydrological cycle salient to erosion. But the philosophical undercurrent swells. Proxima tests whether life is an inevitable outcome of chemistry or a fragile accident. Confined to rare oases, the star's longevity offers time for recovery trillions of years to rebuild atmospheres post-flare. Yet the violence questions if such windows suffice. The escalation culminates in a profound ambiguity. Where Proxima Centauri, once a beacon of proximity, now embodies elusive truths. Observations stacking upon models reveal a system in flux. Its habitability a probabilistic veil rather than a certainty. In this mirror, we see our own world's vulnerabilities, climate shifts, solar storms amplified to stellar scales, urging reflection on stewardship. Ultimately, Proxima b stands as a philosophical lodestar, illuminating the tension between cosmic abundance and existential rarity. A world where hope endures amid the deepening mystery. In the shadowed cradle of the cosmos, where red dwarfs flicker like ancient hearth fires against the infinite night, theories of habitability weave a tapestry of fragile possibility. Proxima Centauri, that diminutive beacon just beyond the sun's reach, hosts a world ensnared in its gravitational embrace, a planet where life might cling. Amid relentless stellar tempests, astronomers, drawing from observations captured by telescopes perched on Earth's high plateaus, have long pondered the barriers and bulwarks that could render such realms viable. Red dwarfs, comprising the majority of stars in the galaxy, burn with a subdued fury. Their cooler temperatures demanding the habitable zones huddle perilously close to their surfaces. For Proxima b, this intimacy means an orbit so tight that the planet likely spins in synchrony with its star, one face eternally bathed in dim red glow, the other shrouded in perpetual darkness, a tidally locked sentinel, frozen in cosmic stasis. The challenges are profound: stellar flares, eruptions of energy far surpassing those of our Sun, unleash torrents of ultraviolet radiation and charged particles, capable of eroding atmospheres like wind sculpting stone over eons. Yet, in this adversarial dance, nature offers countermeasures. Speculative shields forged in the fires of planetary evolution. Consider the role of a thick atmosphere, a voluminous cloak of gases that could absorb and deflect the star's wrath. Models crafted from data gathered by space agencies suggest that high concentrations of greenhouse molecules, carbon dioxide, perhaps, or water vapor might trap heat sufficiently to maintain liquid water across vast expanses. Even on a world divided by light and shadow, such an envelope would not merely insulate. It could scatter harmful radiation, transforming lethal bursts into diffused energy that permeates the air like a muffled thunder. Simulations rooted in atmospheric dynamics observed on Earth and Venus envision layers dense enough to withstand the stripping winds of stellar activity, preserving volatiles essential for life. Magnetic fields emerge as another guardian, invisible barriers generated by a churning molten core, deflecting charged particles much as Earth's magnetosphere repels solar storms. For red dwarf planets, these fields might be commonplace, sustained by the slow cooling of rocky interiors over billions of years, creating a protective bubble that allows atmospheres to endure. And then there are oceans vast, deep reservoirs that could serve as buffers, their depths shielding biological processes from surface onslaughts. If Proxima b harbors such waters, drawn from sea accretions during its formation, they might circulate heat through currents, moderating extremes and fostering stable environments beneath the waves. These theories, distilled from spectral analyses and computational worlds built in laboratories, paint a picture of resilience, a planet not defeated by its star's volatility, but tempered by it, where habitability emerges from the delicate balance of protection and peril. As the narrative deepens, the mind drifts toward exotic forms of life that might rise in such unforgiving realms. Adaptations sculpted by the relentless pressures of flare radiation. And eternal daylight on one hemisphere, life, as witnessed on Earth in extremophilisering in scalding vents or arid deserts, demonstrates an astonishing plastic. Extend this to Proxima b, and visions of organisms attuned to ultraviolet deluges take shape. Perhaps microbes with pigments that harvest infrared and ultraviolet wavelengths, converting stellar flares into metabolic fuel, much like how certain earthly bacteria repair DNA amid radiation exposure. In the tidally locked expanse, where one side bakes under constant illumination and the other chills in unending night, evolution might favor beings that migrate with the winds, or burrow into subsurface niches where temperatures stabilize. Speculative biology, informed by studies of terrestrial analogs, suggests life forms with enhanced repair mechanisms, enzymes that mend genetic strands fractured by particle storms, allowing persistence where fragility would falter. The locked daylight environment imposes a dichotomy. The day side, scorched yet energy-rich, could host photosynthetic organisms adapted to low-light spectra, their biochemistry tuned to the star's infrared dominance, perhaps utilizing compounds beyond chlorophyll to capture photons. On the night side, chemosynthetic life might dominate, drawing sustenance from geothermal gradients or mineral reactions, echoing the deep-sea ecosystems of Earth where sunlight never penetrates. These possibilities, extrapolated from astrobiological models, evoke a world where survival is an art form, life not merely enduring but thriving in the interstices of extremity, a testament to the universe's inventive cruelty. Building upon these foundations, speculative scenarios unfold like hidden chambers in a labyrinthine cave, each revealing layers of potential existence on Proxima b. Envision civilizations clustered in twilight belts that narrow meridian, where day fades into night, a perpetual dusk offering temperate havens amid the planet's divided realms. Here, winds converge, carrying warmth from the illuminated face and moisture from potentialist caps, creating bands of liquid water and stable climates conducive to complexity. Intelligent beings, if they arose, might construct societies along this equatorial ribbon, their architectures adapted to ceaseless scales, their cultures woven around the eternal horizon where the star hangs motionless. Philosophical reflections arise. Would such beings perceive time differently, unbound by cycles of dawn and dusk, their myths centered on the unchanging sky? Deeper still, underwater ecosystems beckon as sanctuaries, shielded from Thesta's flares by overlying depths. Models of ocean worlds, inspired by Europa's subsurface seas, suggest that Proxima b could be an aquaplanet, its surface sedimented by global waters plunging to hundreds of kilometers. where pressure and heat foster hydrothermal vents teeming with life. In these absol realms, radiation's reach diminishes, allowing microbial mats to evolve into intricate webs, perhaps even multicellular forms insulated from atmospheric erosions. The chemistry of such atmospheres diverges from Earth's blueprint. High stellar activity might enrich the air with exotic compounds, nitrogen oxides from flare-induced reactions, or methane plumes from geological outgassing, fostering biochemistries reliant on silicon or sulfur rather than carbon-water paradox. These scenarios, grounded in simulations from climate models coupled with dynamic oceans, whisper of diversity, a planet where life manifests not in verdant forests, but in veiled depths and crepuscular zones, challenging humanity's Earth-centric visions of vitality. Yet, amid this allure of possibility, the Fermi paradox sharpens its edge, casting a long shadow over the silence that envelops Proxima Centauri. If habitability clings so tenaciously to worlds like Proxima b, mere light years distant, why does the cosmos remain mute? The paradox, first articulated in mid-20th century reflections on galactic scales, questions the absence of evidence for extraterrestrial intelligences despite the profusion of stars and potential abodes. For Proxima b, this enigma intensifies. Its proximity invites scrutiny. Yet searches for technosignatures, radio emissions, laser pulses, or atmospheric anomalies indicative of industry yield only the hush of stellar winds. Fleeting signals, like the narrowband anomaly detected in 2019 data from Proxima's direction, stirred brief hope, only to be traced to terrestrial interference. A human echo masquerading as cosmic voice. Why no beacons? No probes, no alterations to the star's light that betray advanced societies. Speculations abound. Perhaps civilizations rise and fall swiftly, their signals dissipating before detection. Or they cloak themselves, wary of interstellar predators. Red dwarfs' longevity trillions of years affords time for evolution. Yet their volatility might extinguish complexity before it broadcasts. The paradox provokes introspection. Humanity's own radiosphere, expanding at light's pace for a century, remains faint at interstellar distances, a whisper lost in noise. If life thrives nearby, the silence suggests rarity of intelligence. Or perhaps a great filter catastrophes like climate collapse or self-destruction that few surmount. In this void, mystery deepens, urging contemplation of isolation. Are we echoes in an empty hall, or merely deaf to subtle symphonies? Delving further into the philosophical undercurrents, speculations of panspermia emerge, proposing that life might traverse the gulfs between stars, carried on the backs of comets and asteroids like seeds adrift in oceanic currents. This hypothesis, rooted in observations of interstellar wonders such as Oumuamua, envisions microbial spores ejected from one world, enduring the vacuum's rigors, and seeding another. Between solar systems, their journey is arduous. Cosmic rays bombard. Temperatures plummet, yet hard organisms, encased in rocky shields, could survive millennia, propelled by gravitational slingshots or stellar explosions. For Earth and Proxima b, separated by 4.24 light-years, such exchanges become conceivable. Ancient impacts on Mars or Earth might have hurled debris toward the Alpha Centauri system, bearing life's precursors. Conversely, comets from Proxima's Oort-like cloud could have intersected our own, depositing shared biochemistry. Studies of meteorites reveal amino acids and complex organics, hinting at universal building blocks disseminated through panspermia. If true, Earth and Proxima might share a biological ancestry, their life forms diverging from a common root, like branches from an ancient tree scattered across the void. This notion blurs boundaries, life not as isolated sparks, but a galactic continuum, where proximity amplifies the odds of kinship. Yet, the rarity of interstellar trends requiring precise trajectories and survival tempers optimism, leaving panspermia as a bridge of possibility, fragile yet profound. Finally, the gaze turns outward to speculative frontiers, where Proxima b beckons as humanity's inaugural stepping stone toward interstellar colonization, a tantalizing target for probes, arcs, and signals that could bridge the stellar divide. Initiatives like Breakthrough Start envision fleets of grand-scale nanocrafts, propelled by Earth-based lasers to fractions of light speed, traversing the distance in decades rather than millennia. These wafer-thin vessels, sails unfurled to photonic winds, would swarm the system, capturing images of Proxima b's clouded visage, sniffing for atmospheric whispers of life. Updates from 2025 reveal progress. Prototypes tested in vacuum chambers. Laser rays conceptualized to sustain push, with swarms offering redundancy against the perils of cosmic dust. Beyond probes, arcs loom in distant visions, generation ships, or cryogenic vessels ferrying humanity's essence. Those centuries-long voyages demand revolutions in propulsion, perhaps fusion drives or antimatter engines, signals to form the vanguard, deliberate broadcasts from radio telescopes, encoding mathematical harmonies or biological blueprints, seeking response across their light years. Proxima b, with its potential habitability, symbolizes the threshold, a world that could host outposts, terraformable perhaps, or a waypoint to farther stars. This pursuit evokes emotional depth saw of humanity's audacity, fear of the unknown voids, reflection on legacy. In reaching toward this crimson-hued enigma, the species confronts its wanderlust, pondering whether to extend life's flame or respect the silence that guards distant shores. The cosmos, in its mysterious expanse, awaits the tentative steps, where speculation yields to discovery, and the nearest star's child becomes the mirror of our aspiration. In the hushed expanse, where human ingenuity confronts the infinite, the saga of Proxima b persists, a spectral presence drawing forth the finest instruments of observation and the boldest visions of exploration. As the veil of distance thins under relentless scrutiny, scientists wield an array of tools, each a bridge across the void, calibrated to unravel the planet's secrets. These endeavors, born from decades of quiet perseverance, transform speculation into substance, probing whether this nearby world harbors the fragile spark of habitability or stands as a sentinel of desolation. The ongoing tests, layered with precision and patience, evoke a philosophical meditation on our place in the cosmos, a quest not merely for data, but for echoes of existence beyond our solitary sphere. Consider the audacious dream of breakthrough start, a venture that seeks to propel humanity's emissaries across the stellar gulf, not in centuries, but in mere decades. Envisioned as a fleet of diminutive probes, each no larger than a postage stamp, these nanocrafts would ride beams of laser light, harnessing the power of photons to achieve velocities that defy earthly bounds. The initiative, fueled by $100 million in foundational investment, aims to dispatch these light sail voyagers toward the Alpha Centauri system, including the red dwarf Proxima Centauri and its enigmatic companion, Proxima b, by accelerating to a fifth of flight's speed. The journey that would span millennia for conventional spacecraft compresses into 20 years. A temporal leap that stirs reflections in the brevity of human ambition against the eternity of space. Recent advancements, as of this unfolding era, illuminate the path forward. Experimental strides at research institutions have tested the resilience of flight sails under immense pressures, simulating the thrust of laser rays that could propel them from Earth's surface or orbit. Innovations in nanotechnology have yielded scalable designs, where ultra-thin membranes, etched with precision at the molecular level, promise efficiency and durability, reducing costs by orders of magnitude through breakthroughs in optical lithography. Collaborative efforts between universities have pioneered materials that withstand the rigors of acceleration. Their surfaces engineered to reflect light with near-perfect fidelity, turning the dream of interstellar flight into a tangible blueprint. Yet suspense builds in the anticipation. These probes, once launched, would streak past Proxima b, capturing fleeting images and spectra in a flyby that lasts mere hours, offering glimpses of surface features, atmospheric hues, or even subtle biosignatures, whispers of life carried back on radio waves across for light years. In this speculative yet grounded interpretation, one ponders the emotional weight of such an encounter, a human-made artifact brushing against another world, a silent dialogue between civilizations, or perhaps the confirmation of profound isolation. As the narrative deepens, the gaze turns to James Webb Space Telescope, a sentinel adrift in the Lagrangian silence, its golden mirror unfurled like a cosmic blossom to capture the infrared secrets of distant realms. This observatory, with its unparalleled sensitivity, endeavors to pierce the atmospheres of exoplanets through methods like transit spectroscopy, where a world's passage before its star betrays the chemical fingerprints of its gaseous envelope. Absorption lines revealing water vapor, methane, or the protective veil of ozone. For Proxima b, however, challenges loom like shadows at dusk. The planet does not transit from our Earth-like perspective. Its orbital plane misaligned, denying the straightforward dimming of starlight that facilitates such analysis. Instead, scientists pursue subtler avenues, such as phase curve observations, tracking the planet's reflected light as it waxes and wanes through its orbital dance, or attempting direct imaging amid the star's glaring proximity. Recent campaigns, expansive in scope, target a cadre of nearby worlds, including those in habitable zones, with dedicated time allocations to discern atmospheric compositions over extended integrations. In August of this year, the telescope unveiled compelling evidence of a giant planet orbiting Alpha Centauri, a sibling star in the same system, its infrared glow suggesting a massive body in a temperature bit. Though follow-up scrutiny tempered the initial exhilaration with calls for verification. For Proxima b itself, the instrument's mid-infrared capacities probe for thermal emissions, potentially mapping heat distributions that hint at atmospheric retention or volcanic activity. Even as stars' flares complicate the signal. Speculatively, if an atmosphere enters, Webb might detect disequilibria gases out of balance, like oxygen paired with methane suggesting biological processes. A credible extension of earthly analogues, where life alters air in detectable ways. This ongoing testing gives mystery, each dataset a puzzle piece, building toward a revelation that could redefine our understanding of habitability, or underscore the harsh realities of red dwarf worlds. Looking further into the cosmic horizon, future observatories emerge as beacons of promise, engineered to surmount current limitations and gaze directly upon Earth-like realms. The extremely large telescope, rising amid the arid heights of Chile's Atacama Desert, embodies this aspiration. Its colossal mirror spanning nearly 14 meters, gathering light with an acuity that dwarfs predecessors, enabling the direct imaging of exoplanets through adaptive optics that correct for atmospheric turbulence, scheduled for first light in the late 2020s. This ground-based Leviathan will resolve rocky planets and habitable zones around nearby stars. Its instruments attuned to spectral signatures of biospheres. For Proxima b, simulations suggest the telescope could discern hints of life, perhaps oxygen or vegetation's red, edging as little as 10 hours of observation. A feat that compresses eons of evolutionary inquiry into a single night. Instruments like Harmony and Metis will dissect light into rainbows of data, hunting for rembrances in atmospheric chemistry that whisper of geological or biological activity. Their high-contrast modules suppressing stellar glare to reveal fervent planetary glow. In philosophical reflection, this capability invites contemplation, the elt not as mere machine, but as an extension of human curiosity, bridging the chasm to touch the essence of another world's story. Complementing these earthly titans are space-borne visions, evolving from conceptual studies into potential realities. The Habitable Worlds Observatory, heir to the ambitions of earlier designs like the Large Ultraviolet Optical Infrared Surveyor and the Habitable Exoplanet Observatory, stands poised as NASA's next flagship endeavor. A telescope optimized for the ultraviolet, optical, and infrared spectra to directly image and characterize dozens of Earth analogs, drawing from decadal surveys. This mission incorporates starshade technology, a deployable occulter that blocks stellar light, allowing the faint planetary reflection to emerge unhindered on advanced coronagraphs that achieve contrasts rivaling the darkness of interstellar voids. Positioned at a stable Lagrangian point, it would survey systems like Proxima Centauri, mapping orbital parameters, atmospheric layers, and surface features with resolutions that discern continents or oceans. Speculative interpretations extend to seasonal variations, where shifts in spectral lines might betray biospheric cycles, akin to Earth's greening with spring, as planning intensifies in this year, with workshops convening hundreds of minds to refine architectures. The observatory represents a culmination of investment, its multi-wavelength prowess a tool for existential inquiry. In this build-up of suspense, one senses the weight of legacy. These instruments, forged from global collaboration, could confirm or dispel the notion of cosmic companionship, altering humanity's self-perception in the grand narrative amid the optical and infrared pursuits. Radio astronomy offers a parallel vigil, listening for intentional signals that might betray intelligent presence, the search for extraterrestrial intelligence. Through projects like Breakthrough Listen, has long targeted Proxima Centauri, its proximity making it a prime candidate for technosignatures narrowband emissions, or modulated waves that stand apart from natural noise. Recent efforts, employing vast radio dishes like the Parkes telescope, have scanned frequencies with exquisite sensitivity, accumulating petabytes of data in quests that span years. A notable intrigue arose from a 2019 detection, a persistent signal at 980 MHz emanating from Proxima's direction, only Tobe attributed later to terrestrial interference, a reminder of the deceptive whispers that permeate the ether. Undeterred, ongoing surveys employ machine learning to sift anomalies, extending to nearby systems like TRAPPIST-1 while maintaining focus on Proxima, where any broadcast, if timed fortuitously, can traverse the void in 4 years. Incredible speculation, a positive detection might manifest as a repeating pattern, encoded with mathematical universals, evoking emotional profundity, the first contact, a bridge across isolation. This patient listening embodies mystery, a philosophical stance of openness to the unknown, where silence itself speaks volumes about the rarity of voices in the cosmic choir. Underpinning these observational forays are thematiculous calibrations of models, digital realms where scientists simulate the intricate interplay of Proxima B's climate, atmosphere, and stellar flares, employing three-dimensional general circulation models. Researchers recreate the planet's tidally locked state, where one hemisphere eternally faces Vesta's crimson glow, fostering stark contrasts in temperature and wind patterns. These simulations incorporate dynamic oceans, their currents redistributing heat to mitigate extremes, potentially sustaining liquid water across vast expanses even under the star's unyielding stare. Flares, those violent eruptions of ultraviolet and X-ray fury, are woven into the equations, modeling their erosive impact on atmospheric layers, stripping hydrogen, dissociating water, yet perhaps replenished by volcanic outgassing or subsurface reservoirs. Advanced iterations explore ozone's role, a shield against radiation, its presence altering circulation and habitability prospects in synchronous orbits. Biosignature studies extend these, hypothesizing surface vegetation that imprints spectral edges, detectable in reflected light, with climate states varying from aquaplanets to arid worlds. In reflective pause, these virtual worlds serve as crucibles for theory, testing resilience against stellar tempests, and guiding observational strategies, a harmonious blend of computation and cosmos. Humanity's investment in Proxima transcends the mechanical. It is an odyssey of the spirit. For this is no distant abstraction but the nearest stellar laboratory, a canvas upon which the questions of life beyond Earth are etched. Resources poured into probes, telescopes, and simulations reflect a collective yearning, a philosophical imperative to confront our solitude or discover kin in the stars. As tools evolve and tests persist, the mystery of Proxima B deepens, eternal invitation to wonder, where each discovery peels back layers, revealing not just a planet, but the contours of possibility itself. In the quiet expanse where the southern constellations carve their eternal paths, the theme of proximity resurfaces like a recurring dream, drawing the gaze back to Proxima Centauri, the Sun's nearest companion. This faint red ember, a mere 4 light years distant, once seemed an empty sentinel, a solitary whisper in the cosmic chorus. Yet, revelations from observatories perched on arid mountaintops and space-borne eyes have unveiled its secret. It cradles a world, Proxima B, a rocky sphere of Earth-like mass nestled in the slender band where temperatures might cradle. Liquid water, discovered through the subtle wobbles in starlight. This planet orbits its host in a mere 11 days, a dance so intimate it defies the vastness of space. Data from high-precision instruments, capturing the Doppler shifts in spectral lines, confirm its minimum mass as roughly that of Earth, positioning it as a potential echo of our own blue marble, a world where rocky terrains might rise under a crimson sky, where atmospheres could swirl in patterns born of stellar winds. This proximity transforms isolation into invitation, suggesting that the universe, in its indifferent architecture, has placed a mirror just beyond our reach, reflecting possibilities that stir the soul. One contemplates the philosophical depths of this revelation, a profound meditation on the abundance or scarcity of life amid the stars. If Proxima B harbors life, perhaps microbial forms clinging to subsurface aquifers, or thriving in twilight crevices shielded from flares, it would illuminate a cosmos teeming with vitality, where the chemistry of existence ignites readily in the warmth of habitable zones. Astrobiological theories, grounded in the uniformity of natural laws, posit that life emerges from the interplay of carbon, water, and energy, processes observed in Earth's extremophiles that endure boiling vents or frozen tundras. Credible extrapolations from laboratory simulations of prebiotic chemistry suggest that under red dwarf light, alternative biochemistries might flourish, with pigments attuned to infrared spectra harvesting energy. In ways alien to our chlorophyll-driven world, such a discovery would affirm life's resilience, implying that the galaxy's trillions of red dwarf systems, each potentially hosting multiple rocky worlds, pulse with biological diversity, a vast web of evolution unfolding in parallel to our own. The implications cascade. Humanity would no longer stand as a solitary outlier, but as one thread in a universal tapestry, challenging anthropocentric views that have shaped philosophies from ancient cosmologies to modern existentialism. In this abundance, one senses a humbling interconnectedness, where the spark of consciousness might echo across light years, fostering reflections on shared destinies in the void. Conversely, if Proxima B proves barren, a scorched relic stripped by stellar tempests, the revelation carries equal profundity, underscoring life's rarity, perhaps its uniqueness in the grand expanse. Recent observations from millimeter-wave arrays reveal Proxima Centauri's flares as ferocious outbursts, releasing energies that dwarf solar eruptions, bombarding nearby worlds with radiation capable of dismantling atmospheres over geological epochs. Studies analyzing these events suggest that without a robust magnetic shield, or rapid replenishment from volcanic outgassing, any nascent biosphere could be extinguished, leaving a desolate landscape etched by cosmic erosion. This sterility would evoke a philosophical solitude, a reminder that the delicate balance required for life-stable climates, protective magnetospheres, and shielded organics might be an exquisite accident, confined to rare oases like our solar system. Astrobiology's frameworks, drawing from the Drake equation's probabilistic musings, highlight how evolutionary bottlenecks, from abiogenesis to multicellular complexity, could render intelligent life vanishingly sparse. Both outcomes, abundance or isolation, resonate with equal gravity, mirroring humanity's dual yearnings for companionship in the stars, or affirmation of our singular narrative. In this dichotomy lies a test of perspective, inviting contemplation on whether the universe is a garden of wonders or a silent monument to potential unfulfilled. Each answer reshaping our ethical stance toward existence itself. The emotional resonance of this cosmic neighbor amplifies across the gulf, a poignant echo of humanity's innate longing for connection in the enveloping dark. For light years, a distance traversed by photons in the span of a child's early years, becomes a metaphor for the almost tangible yet eternally elusive. Proxima B, veiled in mystery, serves as a mirror to our collective psyche, reflecting the ache of isolation that has driven explorers across oceans and philosophers to ponder the heavens. In its ruddy glow, one discerns the shadow of our own world, fragile, resilient, adrift in the infinite stirring emotions that transcend scientific inquiry. Observations from space telescopes, capturing the star's spectral fingerprints, hint at atmospheric compositions that could harbor water vapor or greenhouse veils, fueling dreams of oceans rippling under alien skies. Yet, the flare's violence, documented in bursts of X-ray and ultraviolet fury, evokes a somber empathy, a recognition of vulnerability shared across stellar boundaries. This proximity fosters an intimate bond, as if the universe has whispered a secret. Here lies a sibling world, close enough to ignite hope, distant enough to preserve enigma. In this reflection, humanity confronts its solitude, the emotional weight of gazing into the abyss and yearning for a gaze returned. A silent dialogue that binds us to the stars. Destiny's threads weave through this narrative, prompting reflection on whether humanity might one day bridge the interstellar chasm and alight upon Proxima's enigmatic shores. Concepts born from theoretical physics and engineering envision pathways across the void. Swarms of ground-scale probes, propelled by laser sails to relativistic velocities, could traverse the distance in mere decades, their tiny sensors relaying glimpses of alien terrains. Such missions, proposed in collaborative frameworks, draw on the momentum of light itself, accelerating payloads to fractions of light speed, where time dilates and journeys compress. Fusion-driven rockets, harnessing the power of deuterium-helium reactions, offer another credible avenue, potentially shortening transits to centuries for crewed vessels, with cryogenic stasis or generational habitats sustaining life amid the cosmic night. Yet, the challenges loom like shadowed monoliths. Radiation sieves through the interstellar medium, demanding shields forged from advanced materials. Energy demands rival planetary outputs, requiring breakthroughs in antimatter containment or beamed propulsion. Speculatively, if wormholes or Kubier-metric swarped spacetime bubbles grounded in general relativity prove navigable, the gulf might shrink to days, transforming destiny from aspiration to inevitability. Will we step onto Proxima B's surface, our boots imprinting foreign soil, unraveling its secrets in person? Or will it remain a dream, a beacon across unreachable expanse, testing our resolve against the universe's implacable scales? This contemplation evokes a philosophical tension between ambition and humility, where destiny hinges on ingenuity, reminding us that the stars, though near, demand a reckoning with our limitations. Time's inexorable flow casts a longer shadow in this reflection, as Proxima Centauri's enduring flame contrasts sharply with our sun's fleeting brilliance. Red dwarfs like Proxima, with masses a fraction of the sun's, fuse their hydrogen cores at a languid pace, extending their main sequence lives to trillions of years epochs that eclipse the universe's current age of mere billions. Astronomical models, simulating stellar evolution through computational hydrodynamics, predict that while the sun will swell into a red giant in 5 billion years, engulfing inner worlds in fiery demise, Proxima will persist, its faint red glow unwavering as galaxies merge and stars fade, long after Earth's oceans boil away and its biosphere dissolves into cosmic dust. Proxima Centauri will endure, a steadfast guardian over its hidden realms. This temporal disparity invites profound meditation. In Proxima's longevity lies a vision of eternity, where potential worlds like Proxima b might host life cycles spanning eons, evolving intelligences that outlast our own fleeting spark. Credible interpretations from astrobiology suggest that under such stable illumination, biospheres could achieve complexities undreamt, with civilizations rising and falling in rhythms attuned to galactic timescales. Yet, the flare's persistence tempers this optimism, as ongoing observations reveal outbursts that could periodically reset evolutionary clocks, enforcing resilience or oblivion. In this asymmetry of time, one senses a philosophical melancholy, the universe's indifference to our brevity, coupled with awe at the red dwarf's quiet defiance, a beacon illuminating the impermanence of all things. As the narrative draws to its emotional close, Proxima Centauri transcends its role as a mere astronomical entity, emerging as a philosophical anchor in the human quest for meaning. No longer just a point of light in telescopic fields, it embodies the interplay of possibility and peril, hope and eternity. a cosmic touchstone that grounds our reflections in the tangible nearness of the stars. In its trinary dance with Alpha Centauri A and B, one discerns the harmony of gravitational bonds, a metaphor for interconnected fates across the void. Philosophical discourses in astrobiology underscore this shift. The search for life beyond Earth reconfigures our ethical frameworks, urging considerations of stewardship toward potential extraterrestrial ecosystems and the moral imperatives of exploration. If Proxima b pulses with life, it demands a re-evaluation of anthropocentrism, fostering a cosmic ethic where diversity enriches the universal narrative. If silent, it amplifies the preciousness of our own existence. A call to preserve the fragile miracle on this pale blue dot. The emotional undercurrent swells a blend of wonder and wistfulness as humanity gazes toward this nearest neighbor, finding in its mysteries a reflection of our deepest aspiration. Eternity whispers through its enduring light, a reminder that while empires rise and fall, stars like Proxima persist, guardians of untold stories in the infinite night. This anchor invites a final vision. Imagine the red dwarf's glow persisting through cosmic ages, its planets perhaps teeming with resilient forms, or etched in sterile beauty witnessing the universe's slow unraveling. Data from stellar surveys affirm that red dwarfs dominate the galactic census, their longevity ensuring that the cosmos remains illuminated long after brighter suns extinguish. In this enduring presence, possibility lingers. Subsurface oceans on Proxima b might harbor chemisynthetic webs, evolving in isolation from surface tempests, their biochemistry a testament to life's adaptability. Philosophical implications ripple outward, challenging dualities of self and other, finite and infinite, as astrobiology bridges science and metaphysics. The ethics of contact emerge: how to approach a world that might echo our own. With reverence or curiosity, emotional resonance deepens in this contemplation, a longing tempered by awe, where the nearest star becomes a symbol of hope's persistence amid danger's shadow. Destiny's horizon expands in this reflective close, as concepts of interstellar communion evolve. Probes propelled by electron beams or matter-antimatter drives, theorized to achieve velocities nearing light's limit, could relay spectra revealing biosignatures, methane plumes, or oxygen imbalances, bridging the emotional divide. Yet, the gulf's immensity fosters humility, a philosophical acceptance that some dreams remain aspiration, fueling innovation in their unattainability. Time's vast canvas paints Proxima as an eternal sentinel. Its trillions-year span a canvas for speculative narratives, worlds where life, if present, might contemplate us in return, their signals lost in the interstellar haze. Ultimately, Proxima Centauri anchors us in eternity's embrace, a philosophical lodestar where possibility dances with peril, hope with the unknown. In its faint red light, humanity finds not answers, but the profound beauty of the question itself, a mirror to our soul amid the stars. In the vast tapestry of the cosmos, where threads of light weave destinies across incomprehensible voids, the reckoning with Proxima Centauri rives like a long-shadowed dawn. illuminating not just a distant star, but the contours of human existence itself. For light years away, a span that echoes with both intimacy and isolation, this red dwarf beckons. Its faint crimson glow a subtle challenge to the hubris of earthly observers. By human measure, this gulf stretches beyond lifetimes, a journey that would consume generations in the slowest vessels of steel and fire. Yet in the grand architecture of the universe, it whispers of proximity, a mere step across the stellar threshold. For millennia, gazers have lifted toward luminous giants blazing across billions of light years, their stories etched in ancient spectra. While this nearest neighbor lingered unnoticed, a quiet ember in the southern skies, the irony unfolds slowly, the answers to humanity's most profound inquiries about origins. Solitude and endurance may reside not in the remote blaze of quasars, but in the subdued radiance of this unassuming star, orbiting at the edge of the Alpha Centauri trio, a system that has danced in gravitational harmony for eons. Proxima Centauri transcends its celestial form, becoming a mirror polished by cosmic indifference, reflecting the fragility of a species adrift on a pale blue dot. In its dim light, one discerns the restlessness that propels telescopes toward the heavens, the innate urge to pierce the veil of night and confront the unknown. This star, with its modestness a fraction of the sun's, burns with a thrift that promises longevity, a slow combustion that could span trillions of years, outlasting brighter kin bioters of magnitude. It serves as a reminder of transience, while our sun swells toward eventual engulfment. In 5 billion years, Proxima endures, a sentinel of time's inexorable flow. In this reflection, humanity's curiosity emerges as both a gift and a burden, a flame that illuminates but also consumes, driving quests that span from ancient stargazers charting myths to modern astronomers passing data streams from orbital sentinels. The star's proximity amplifies the philosophical tension, so close, yet veiled in mysteries that test the limits of ingenuity, forcing a confrontation with their boundaries of knowledge and the whispers of what might lie beyond. As the narrative deepens into the realm of possibility, the weight of discovery presses upon the collective soul. What if life, in some form, clings to the rocky shores of Proxima b, that Earth-sized world nestled in the star's habitable embrace? The mere confirmation of alien microbes, faint traces etched in atmospheric spectra or subsurface echoes, would fracture the foundations of thought, reshaping philosophies forged in isolation. Religions, long anchored in the notion of a singular creation, would grapple with the divine extended across stellar divides, prompting gratitude of sacred texts and the role of humanity in a popular tedcosmos. Science, too, would undergo a seismic shift. Theories of abiogenesis validated or upended by the chemistry of another world, revealing life's emergence not as a terrestrial anomaly, but as a universal inevitability, woven into the fabric of carbon, water, and stellar forges. The emotional resonance spirals like a gathering storm. No longer would Earth stand as the sole cradle, but as one thread in a vast web, where life's tenacity defies the void. Biosignatures, gaseous imbalances, like oxygen's abundance or methane's persistence detected through spectral lines, could signal metabolic processes mirroring those that greened our planet billions of years ago. A credible echo of evolutionary parallels, and speculative, yet grounded extension. Envision a history where intelligent life once flourished on Proxima b, only to succumb to the star's relentless temperament. Radiation storms, those violent fluorescerting with energies dwarfing solar outbursts, could have stripped atmospheres and sterilized surfaces, erasing civilizations in cataclysmic waves. Geological upheavals, volcanic upheavals, or tectonic rifts might have buried their remnants beneath layers of regolith, leaving fossilized echoes or ruined artifacts adrift in the dust. What if probes, one day piercing the void, uncover not thriving ecosystems, but the petrified ruins of societies, their technologies silenced by cosmic forces? This vision evokes a profound melancholy, a poetic lament for what was lost. The closest neighbor might not greet with vitality, but with the silence of extinction, a warning inscribed in stone and shadow, urging reflection on Earth's own vulnerabilities to solar whims or internal discord. In this mystery, life becomes not eternal triumph, but a fleeting symphony, harmonizing briefly against the discord of stellar fury. Yet the scales balance with equal gravity in the absence of life, a void that resonates with its own profound implications. If Proxima b, despite orbiting within the zone where liquid water might pool, reveals itself as barren, its surface scorched, atmosphere eroded by ultraviolet barrages, the revelation underscores that habitability demands more than mere positioning. Magnetic fields to deflect charged particles, geological activity to recyclements, or fortuitous shielding from flares, all absent, perhaps. Infestedly locked world where one face bakes eternally while the other freezes in perpetual night. Such emptiness would amplify the rarity of Earth, suggesting that the confluence of factors birthing complex biospheres occurs sparing Gliacris, galaxy, perhaps uniquely in our solar nook. The emotional burden deepens. Humanity, as stewards of this singular flame, would shoulder a heavier mantle, the imperative to preserve biodiversity and planetary health intensified by the cosmos's apparent indifference. In this scenario, Proxima emerges as a tomb of unrealized potential, a jewel devoid of inner fire, its rocky expanse a canvas unpainted by evolution's brush. The philosophical echolingers, in a universe teeming with worlds yet silent in their sterility, life's spark becomes a miracle to cherish, a fragile legacy demanding vigilance against self-inflicted oblivion. This duality ignites humanity's longing to cross the divide, a primal urge manifesting in visions of interstellar voyage. At the forefront stands the Breakthrough Starshot Initiative, a symphony of engineering where sails of ethereal thinness, crafted from nanoscale lattices, harness laser beams to propel probes across the abyss. Recent strides, as of this era, illuminate the path. Experimental validations at Research Bastion Shave tested these light sails under simulated thrusts, scaling designs to withstand accelerations that hurl them toward a fifth of light's velocity. Innovations in optical fabrication have slashed costs dramatically, rendering once prohibitive arrays feasible through precise etching of reflective membranes. Collaborative forges between institutions have pioneered resilient materials, their structures defying the rigors of launch and the interstellar chill. Envision these grand-scale emissaries, adrift on photonic winds, traversing for light years in decades rather than the millennia of chemical propulsion. Their instruments capturing snapshots of Proxima B's visage, perhaps cloud vistas, or barren craters beamed back across the ether. The suspense of such a crossing builds in the mind's eye, probes fragments of human ambition, navigating radiation belts and micrometeor swarms, riving to orbit or fly past. Their data bridge to the alien. In speculative horizons, future descendants might follow. Vessels powered by fusion or a time matter carrying colonists to step beneath Proxima's ruddy sun, witnessing its rise over undulating dunes or crimson seas. This travel transcends mechanics, evolving into a rite of passage, a metamorphosis where humanity sheds planetary confines to embrace cosmic citizenship, forging alliances with the stars or confronting the solitude they impose. The emotional undercurrent swells. In bridging this nearest gap, the species affirms its resilience. A narrative arc from cave-bound wonder to interstellar wanderers. Deeper still, the reckoning extends into temporal abysses, where stellar chronology's dwarf mortal spans. Proxima Centauri, as a red dwarf, embodies endurance, its hydrogen fuel sipped with parsimony, sustaining fusion for trillions of years far beyond the sun's billion-year arc. In this faint glow resides a future etched in cosmic ink, outlasting the expansion of brighter stars into red giants, their planets consumed in fiery embraces. If humanity persists through epochs of challenge climate upheavals, resource scarcities, or self-route perils, Proxima could transform from neighbor to refuge. Its stable light nurturing worlds for civilizations yet to dawn. Speculatively, long after Earth's oceans boil away under a swelling sun, descendants might migrate to Proxima b or its siblings, adapting to red-tinted skies where photosynthesizes round infrared peaks. Life rekindled in a new stellar hearth. This vision stirs a philosophical awe. Time's vastness renders human history a mere prelude. Proxima a cradle for continuations, where the seeds of terrestrial life bloom anew amid dust belts and potential moons. A red-lit saga unfolding in eternal patience. In the culmination of perspective, Veracurning crystallizes. Proxima Centauri embodies paradox near yet unattainable. Hospitable in theory yet hostile in practice, a beacon of hope laced with admonition. Recent revelations heighten the intrigue. Telescope Shave unveiled a sibling world in the adjacent Alpha Centauri system, a gas giant hinting at hidden architectures. While closer scrutiny of Proxima brevels flare-driven inhospitality, its potential atmosphere likely stripped bistellar tempests. A newfound companion, Proxima d, orbits nearer still, a sub-Earth mass adding layers to the system's complexity. Yet the core mystery endures. Humanity lingers at this threshold, the universe proffering a neighbor without yielding secrets, compelling choices in the face of ambiguity. The true reckoning lies not in life's presence or absence, but in the response it evokes, the forging of unity, the pursuit of sustainable legacies, the ethical navigation of discovery. In meditative eclipse, if Proxima harbors life, isolation dissolves, weaving us into a galactic chorus. If barren, rarity elevates our charge, a solitary light tears our fegwood. Either path unfurls the human story anew, with the closest star a sentinel summons. drawing forth the essence of what it means to wonder, to seek, and to become.